Hello there. Today we have an interesting problem called unlock rooms. In this particular problem, we are given a two-dimensional list of integers called rooms, each of the index of I in rooms representing a room and rooms I representing different keys to unlock other rooms. You are given an unlocked room 0 and each other room is locked. Given you can move freely between unlocked rooms, return whether you can unlock every room. Okay, so first of all, let's think about what we're going to try to do. We are going to get a key, and we're going to use that key to open up other rooms. Let's say in example 1, we get the key to room 0, and we try to unlock room 1 and 3. And we take the key and we unlock 1, and we now get another key. This key is 2 and 3. We get no key. With the key 2, we can unlock room 2 and we get the key 0. Of course, room 0 is already open, then we no longer have to open it. So we want to keep a track of the number of rooms we unlock, because if we don't, we will be in an infinite loop of taking the old key and opening a new room. Anyways, if we can open all of these doors, which is 0 through 4, the length of the rooms, then we have completed our assignment, and we have unlocked all the rooms. So one way we can do this is to do a depth first search, which involves using a stack or recursion. And otherwise, we could use a breadth first search as well to unlock every room, because if we're just throwing everything into a queue and unlocking a room, we can also do it using recursion. First of all, I'm going to do this iteratively. Then I'm going to do it recursively using a DFS method. Then I will use a iterative breadth first search and then a recursive breadth first search. So I'll be presenting 4 solutions here today. Okay, let's begin. So first of all, like I said, we're going to create the unlocked rooms to remember which rooms that we have been to, because we don't want to revisit the rooms that we have already been to. If we do, then we're going to be stuck in an infinite loop. First of all, we're going to get the key 0th key. So while stack key equals stack dot pop. So we're going to pop the item off the stack. So keys is equal to rooms of key. We're going to open that particular room, that particular key. For key in keys, if not unlocked, then we're going to unlock it and get the key out of it. So once that is unlocked, we append the key, we repeat the process, and we return all of unlocked. Have all the doors been unlocked. And let's run this and submit. Perfect. So we have a pretty good run here, and let's get the recursive version of this. So recursively speaking, let's take all of this out. It's gonna remove all that, and let's create a recursive point. So everything is false times the length of the rooms. So what happens here is we define a recursive function called dfsi, and if unlocked I, we're going to return. Otherwise, unlocked is I is equal to true. And what happens now is that we set the keys to rooms of I, and for key in keys, we're going to visit every single room. And we run dfs of 0 and return unlocked. So what is going on here, right? So what happened exactly was that we did a recursive call. So what that means is that we take all the keys in one, and we take that first key, and we're going to go through and check the first item. Then we're going to find 2. And so we took the first key and we threw it into the keyhole of 1 and got the key 2. And then for that one, we have now unlocked the 0 and 1. And now we have the key 2 here in this particular process. And we put the key in and we check out 2, which has the key 0. And we check out key 0 and we go back and we check 3, which is depth first search. The same can be said about the stack, where we throw in the items, you know, we'll check of course, the first item of the stack, and first, and go to 3, and then go to 3 other ones. So anyways, this is how we solve it. Run the code. Oh, whoops. Let's see what happened here. Return. Oh, all unlocked. Right, so perfect. So now we are done with our depth first search. We're gonna do a breadth first search now. We're gonna do a queue to get through this, and let's do it. So same thing as before. We're gonna record all the true items and false items. Basically what has been unlocked, what has not. And this time, instead of a stack, we're gonna use a queue. This is pretty much like the stack version, except instead of first in last out, we're gonna do first in first out. Length of the queue is greater than 0, and I is equal to queue.pop left. So we're gonna pop the first item off the queue. And you could say this is a key, which is better. Right. So for key in room of key, we're gonna, if it's not unlocked, then we're going to append the key, and we're gonna unlock the door. We can also unlock the door first and add the keys. But I think it makes more sense if we unlock the door first and then take all the keys inside the door. So we're gonna flip that. And we're gonna run all unlocked. So the difference between this one, the stack and the is only the difference between the depth first search and the breadth first search is that we're gonna use a queue instead of a stack. Let's see, n. Right. So this is the length of the rooms. Run. Right. And we have another, solve this problem once again. Okay, so this is our last solution out of all the solutions. We're going to use breadth first search. So this is going to be rather interesting. Instead of appending the key to the queue, I guess, so instead of using a for loop, what is the difference anyways? There's not much of a difference. But let's do it. So what's going to happen is that we have all the same items, and instead of running a while loop, we're going to collect all these parameters and make sure the length of the queue is, if it's equal to 0, that means there's nothing in the queue anymore, return. And while the length of the queue is greater than 0, we're going to get the key from that particular queue, and for each key in keys, we're going to run the same code, exactly the same, except what we're gonna do now is that we're going to run BFS one more time. And you might wonder, why the heck are we doing that? Yeah, why the heck are we doing that? So instead of a while loop, we use a for loop here. For key in queue. For in queue, we can, and then we can do for key in room, and we can append it to a new queue, next queue, and we append all those items to the next queue, and we try the next queue. I think that's it. Yeah. And then we run the BFS in rooms, queue, and unlocked. Okay, looks like it worked. And yeah, that's it. So the difference here is that we use a for loop to get all the keys. We don't actually need this for loop. What we can do here is we just pop the first key off, and we check that particular item, and we pop left q.pop left I key, and for rooms in key, we're gonna append the item into queue, and we're gonna run the next loop rather than, and we're just gonna keep popping. Let's run it and submit, and it worked again. Great. So instead of having a while loop and a for loop inside, we're just using a for loop and then using a BFS to handle the while loop. And that's all for the BFS. Let me just clean up this code a little bit, and that's great. Perfect. That's all we're going to do for this video. It's getting pretty long already, 13 minutes. But thank you very much for watching. If you have any questions or comments, please comment below. If you enjoyed the video, like and subscribe. And if you want more videos, please check out the link in the description below, and you will find more of my what I've been working on. Thank you very much, and have a good one.